Solving inequalities. An inequality is like an equation, but instead of an equal sign, it will have these signs. Now, one key note that I want you to notice is at the bottom of this slide, you see the number line. And the number line is used to picture the actual solutions for our inequalities. So the first inequality sign that we're going to discuss here is the less than sign. If our variable is on the left-hand side, it is indicating that our number for that variable is every number less than the indicated number. So if we would have a less than -2, well, then we would know that our values for the variable could be a -2.5, it could be a -3, everything less than the number that it states. The other symbol is the less than or equal to symbol. Now that means that it also includes the number that it's less than. So it includes the number and every number below that. But when you just have the less than, it doesn't include the number. It just means it's every number below. A way of remembering what the less than symbol is, because when you see the inequality, it's very important that you know what it is. The less than symbol, if you were to straighten it out, will look like an L for less than. So one way or a trick of remembering what the less than symbol is, if you straighten out the symbol and it forms an L, then it's the less than symbol. The next symbol that we're going to talk about is the greater than, and that indicates that every value for the variable is greater than or larger than the number that it's assigned. And then if we have the greater than or equal to, it will have a line underneath the inequality symbol to represent that it also includes the number. So these are our inequality symbols. Part of the solution for inequalities is the graph of the solution. So when we have a less than symbol, and again, if I straighten that out, I know that it's a less than because it forms an L. If it's a less than, when we graph it, would use an open circle. That will indicate that it does not include that number, but it's every number below. And you shade the number line to the left to indicate that all my solutions are less than that answer. And in this example, we have x is less than 0. So at 0, I use an open circle, and I shade the number below 0. And again, when you're doing the less than, it's numbers that are lower than the number it's indicated. If you have a less than or equal to, well, that means it includes it. And to represent that, when we graph, we close the circle where that number is indicated. So in this case, my x value is less than or equal to 0. So at 0, I'm putting a closed circle, and I'm shading to the left. Now, I want you to also notice another little trick here. If the variable's on the left-hand side, notice that the inequality symbol looks like an arrow, and it's pointing in the direction of which we should shade. So if the variable's on the left-hand side, the inequality symbol will point in the direction we should shade. Now, when we have the greater than symbol, again, if it doesn't have the equal to or the line underneath, then again, it doesn't include it. So we would have an open circle at 0, and in this case, we're shading to the right to indicate that all my numbers are getting larger and larger, that my x values can be any number from 0, not including 0, and above. When you have the greater than or equal to with the line underneath it, that means it also includes it. So when you see x is greater than or equal to 0, that means that x can be 0, and it's going to be every number above 0. So this is how you would represent your solution as an inequality. And also, key note here, look at the inequality symbol. When the variable's on the left-hand side, you notice that the inequality looks like an arrow and points in the direction that we will be shading. So notice this, if I'm looking at the inequality symbol and I see that it is on the variables on the right hand side, I can switch this around so that I can see the direction in which my solutions would be shaded. Now, if you don't want to flip it around, if the variable's not on the left-hand side, no, you have to shade in the opposite direction, because this means that my x is less than or equal to a -2. I'm kind of reading it backwards. So one way that I do it is I would flip my notebook upside down or flip my paper upside down to get the x on the left-hand side. When you flip it upside down, the x gets on the left-hand side, and I can see the direction that the inequality is pointing in, and then I can graph my solution. So x is less than a -2 means I have a closed circle at -2 and I shade to the left. So you have to be careful. If the variable's not on the left-hand side and you want to graph the solution, either remember you have to graph in the opposite direction of the arrow that the inequality is pointing, or turn your paper upside down and it'll show you the direction that you should have your inequality. So when we're solving inequalities, when we isolate the variable on one side of the inequality, you're following the steps for solving an equation. But one key rule that you're going to need to remember is at the very last step, if you're solving and you have to multiply or divide by a negative number, you have to flip the inequality symbol. If you're solving an equation and the very last step you multiply or divide by a negative number, you have to flip the inequality symbol. So I'm going to show you what it would look like. If I did a multi-step inequality and I got to this step, I have one more step to solve for x, and I see that I have a -5 attached to the variable. Well, what that means is I need to divide by a -5. And when I divide by that -5, that's where that rule comes into play. I have to flip that inequality symbol. Because it's a -5, that inequality symbol needs to flip. And my solution would end up being x is greater than or equal to a -2. So it's very important to remember this rule. The very last step, if you're multiplying or dividing by a negative number, you need to flip the inequality symbol. Now be careful, because when you see something like this, the last step here is I have to divide. But I'm dividing by what's attached to the variable, and what's attached to the variable is a +5. So because I'm dividing by a +5, I don't need to flip the inequality. It's only when you divide by a negative number. Now I know that I'm going to end up with a -2 as my inequality value, but I'm not dividing by a negative number to solve. I'm dividing by a positive. So therefore, in this case, I would not flip the inequality. I would end up with x is less than or equal to a -2. So I want you to notice the difference between the two. Be careful when you're solving inequalities. So if we were to do a two-step inequality, similar to a two-step equation, you want to first do or undo the addition or subtraction with the inverse operation, and then deal with what's attached, whether it's multiplication or division. So to undo or to do a two-step, you're following the same steps you would if it was an equation. So here's an example. I have 8x plus 5 is less than or equal to 61. I want to isolate the variable. This is a two-step inequality. The first thing I'm going to do is subtract. Because I have a +5, I want to subtract 5. I subtract it from both sides of the inequality, and now I have to divide. And at this step, I'm thinking, am I dividing by a negative? No, 8 is positive, so I'm dividing. My inequality stays the same, and now I can graph. So I see x is less than or equal to 7. Therefore, it's going to be a closed circle because it's including 7, and it's every number below 7, so I would shade to the left. Now notice this one. I have a coefficient or a negative in front of x. That means that I have not completed my solution. So you might have a multi-step inequality and get to this step. Well, you have to continue until the coefficient of the variable is a +1. So in order to solve this, I'm going to need to divide through by a -1. Now remember that rule, I'm dividing by a negative, and whenever you divide by a negative, you need to flip the inequality symbol. So in this case, my solution would end up being x is less than a negative 19. So be really careful. You're going to have to flip the inequality whenever you divide by a negative. So now I would graph my solution. It's an open circle at negative 19, and we shade to the left. Now I want to do another two-step equation here, and I want you to notice I have a fraction in it, but it's a two-step equation. Don't let fractions throw you off. The first step you're going to do here is add the 9 to both sides. Add the 9. You're just going to bring down that fraction. 5 over 7x is greater than a negative 20. Don't forget that rule, different signs, subtract and keep the sign of the higher number. That's where that negative 20 is coming from. Now I want to get rid of the fraction in front of x. I want that coefficient to be a 1. Now remember, to get a coefficient of a 1 when a fraction's attached, you use the reciprocal. The reciprocal of the fraction will get me a coefficient of 1. So whatever you do to one side of the inequality, you have to do to the other. So that reciprocal gets multiplied to both sides, and that cancels down, so I get a coefficient of 1. Now on the right hand side, when I'm solving, because it's a whole number, I want to put it over 1, and I want to simplify first and multiply across. So here I'm going to simplify the 5 into 20, and it's going to be 4. And don't forget here, we have a negative sign. So you don't want to lose your signs when you're doing problems like this. So we have a negative 4 times 7, which will give me a negative 28. So in this case, my solution will be x is greater than a negative 28. I'm going to graph my solution. It's an open circle at negative 28, and I shade to the right. So now look at this example. I want to solve for the variable, but I see I have 26 minus 3x. Don't let this throw you off. I need to get rid of what's around the variable before I deal with what's attached to the variable. So I want to move that 26 over, and 26 is positive, so the inverse operation would be subtraction. So I'm going to subtract 26 to both sides to remove the 26, and I'm left with a negative 3x. That minus now becomes the negative to the 3. Negative 3x is greater than or equal to 6. Now I need to divide, and I have to think of that rule. I'm dividing, this is my last step, and I'm dividing by a negative. Whenever you divide by a negative, that means I have to flip that inequality symbol, then I end up with a solution, x is less than a negative 2. So now I'll graph it. It's a closed circle at negative 2, and we shade to the left. Now notice this inequality. We have an expression over top of a number. Well, in order to get to that expression on top, I need to deal with that division. That 3 is dividing into that entire expression. So in order to get rid of that 3, because it's division, I need to do the inverse, which would be multiplication. Now that's removing that division. That gets rid of the 3 in the denominator or in the divisor so that I can get to the expression. So I'm left with x plus 2 is less than 21. And now it's a one-step inequality. I subtract 2 from both sides, and I get my solution. X is less than 19. And I'm going to graph my solution. It's an open circle at 19, and I shade to the left. Pause and try. First step, I'm going to subtract 11 from both sides. I'm left with negative 3 is less than a negative 6. I have to divide, and I'm dividing through by a negative, which means I need to flip that inequality symbol. Don't forget to think of that rule at the last step. I graph my solution. It's going to be an open circle, and I'm shading to the right. Pause and try. This is a two-step inequality. The first thing you're going to do is get rid of the plus or minus, so you're subtracting 5 here. Now remember, when you have x over a number, that's division. And we have x being divided by 2. We have to do the inverse operation of division, which is multiplication. So I'm going to multiply both sides by 2 to have my isolated variable. So I end up getting x is greater than a negative 28. I graph my solution. It's an open circle, and we shade to the right. Pause and try. So I'm going to add 6 to both sides here. I'm left with the fraction. Remember, we want that coefficient to be 1, so we're going to multiply by its reciprocal. That's going to get that down to a coefficient of 1. I'm going to put that whole number over 1, simplify, multiply across, and I get my solution is x is less than or equal to 20. I graph my solution. It's going to be a closed circle, and I'm shading to the left. Pause and try. So again, to get to that expression up top, the first thing I need to do is multiply both sides by 5 to eliminate that division. And now we're left with x minus 6 is less than or equal to 55. I'm going to add 6 over, and I get x is less than or equal to 61. This is going to be a closed circle at 61, shaded to the left. So now when we're doing multi-step inequalities, we use the same process we would for equations. If there's the distributive property or parentheses in the inequality, that's the first thing you will need to do. Then you want to combine like terms. And remember, like terms are on the same side of the inequality. So you're going to add or subtract the coefficients, or you're going to combine the constants. Then you want to start moving. If variables are on opposite sides of the inequalities, you're going to want to move them together. To do that, you have to do the opposite. So remember, when you move from one side of the inequality to the other, you have to do the opposite to move it. Once you get to this point, you'll have a two-step inequality or a one-step inequality, which means you're going to undo the addition or subtraction and then deal with what's attached to the variable, whether it's multiplication or division. So let's do this example here. We have the distributive property, so the first step we're going to take is take that number and multiply it to everything inside. Always double check your arithmetic. 3 times x is 3x, 3 times 5 is 15. Everything else just comes down. So I have the plus 3 is greater than or equal to 51. Now I want to combine like terms, and my like terms here are those constants. Plus 15 plus 3 will become plus 18. Now I have that two-step inequality. I'm going to undo the addition or subtraction. So I'm going to subtract 18 from both sides, and now I'm going to divide. And always think of that rule. Am I dividing by a negative? No, therefore the inequality stays the same. And I get my solution is x is greater than or equal to 11. And I'm going to graph the solution. I'm going to have a closed circle, and I'm shading to the right. Pause and try. Okay, so you're going to do the distributive property here. You end up with 6x plus 30 plus 8 is less than a negative 10. Combine like terms, you get 6x plus 38 is less than a negative 10. Now it's a two-step inequality. Subtract 38 from both sides. You get x is less than a negative 48. And we're dividing through by 6. It's a positive, so it's not going to flip. And we end up with x is less than a negative 8. We're going to graph the solution. It's going to be an open circle at negative 8, and we shade to the left.